Mark, for Thanks, Mark, for getting us rolling there. I'll start over with the recording, so I'm covered there. So welcome everyone to our session today. It is Introduction to Retro Commissioning. We have about a 90-minute session planned. We'll leave some time at the end for questions, but as Mark indicated, if you can write your question in the Q&A box, we'll follow up with any questions you have, and we'll field some questions along the way if they're pertinent and help make sure that the session is clearer. So our speakers today, I want to move on to our next slide and talk about our speakers today. So we have Ajit Naik, who is our Vice President and Senior Commissioning and Energy Engineer at Baumann Consulting. A number of years of experience across the industry in building, helping us make high performance buildings the norm. And so he'll be covering a lot of the basics of retro commissioning and how it benefits things, as well as some introduction to BEPS. And then we have Hardik Miani, who will share with you some real world experience with retro commissioning and some really good examples of activities that we have with retro commissioning. He has a master's degree in energy engineering and systems, and has really good experience as a senior commissioning engineer with Baumann Consulting. And then I'm just here as the MC, but I'm the Vice President of Baumann, Senior Vice President of Baumann Consulting and head of our Washington, D.C. office. And I'm a mechanical engineer by training and a licensed engineer here in Washington, D.C., Virginia, and Maryland, and cover a lot of the bases here as well with retro commissioning, energy audits, and whatnot. So we'll hopefully cover any of your questions, but more importantly, have a good session to get you introduced to retro commissioning for commercial buildings. With that, I'll hand it over to Ajit and let him take it from there.
Cheers. Thanks, Scott. So thank you, everybody, for joining our presentation today on an introduction to retro commissioning. We have a few learning objectives here. Really, we want to understand how BEPS motivates building owners to reduce their property's energy usage, what retro commissioning is and what role it plays in helping building owners reduce their energy usage, what are the steps involved in the process, and some lessons learned from the war stories, basically from our experience retro commissioning on the projects in the past. So before we get started here, I just wanted to ask the audience here, what's your background? People who are building owners, managers, engineers, design team members, commissioning providers, contractors, or others. So we'll leave this poll open for maybe just like another 30 seconds or so that people respond. About 50% of folks responding. Okay, looks like the majority of our folks are in the other category. I would love it if, just for our own reference, you could punch into the chat there real quick, those of you who are in the other category, what your background is. But it sounds like we have a mix of folks today from a variety of different backgrounds, so that'll make a good audience for today's presentation. So wanted to start out by talking about BEPS. Folks in DC have been hearing a lot about BEPS from a lot of different folks around the district, but it's worth bringing up again as a framing device here. So BEPS is the Building Energy Performance Standard in Washington, D.C., which grades your building on a curve. It basically requires you to report your building's annual energy performance, and it compares it against the peer buildings. The way that the buildings are graded specifically is by being given an Energy Star score. So the Energy Star score is generated through the EPA's Portfolio Manager website. Basically, buildings all over the country, in DC and around the nation, report their energy usage, their monthly utility bills to this website, and provide some characteristics of their building, what it is, how big it is, when it was built. And the EPA crunches these numbers and assigns the buildings a score. The median building for your type nationwide gets a score of a 50. Buildings that have a higher score than a 50 are more energy efficient, and buildings that have a lower score than 50 are less efficient than the median. So most buildings in DC can get an Energy Star score. There are some building types that are not eligible, but generally most can. The energy usage is, the scores are weighed in terms of source energy and not site energy. The difference between these two is that it isn't just, how much electricity you're using at the plug or at your meter. Source energy also accounts for all the losses that happen between where the electricity was generated at the power plant and you. So the inefficiencies of transmission across power lines, all of that's accounted. So even though you might only use 100 units of energy at the source, at your site, at the source along the way, 120 units of energy might have been burned to make that possible. So the Energy Star score is given in terms of source energy and is used to compare you against your peers. In general, as we continue through this conversation, when we talk about BEPS and reducing energy, we're mostly talking about site energy. That's what you're using at your site. But whenever we talk about targets, we talk about Energy Star scores, which are given in terms of source energy. So how BEPS will work. So DC, the district, has required buildings to benchmark their energy usage for years now. But really only recently has it become actionable, doing something with it. So in 2019, all buildings that were covered by BEPS had to report their building energy usage. For those buildings that didn't meet the BEPS target, that target Energy Star score for their building type, were placed into a compliance cycle starting back in 2019. These buildings have a few different options to bring their buildings into compliance with BEPS by 2026, or else face large fees. You can see right now, the first BEPS cycle, which started in 2019, covered private buildings over 50,000 square foot and public buildings over 10,000 square foot. But after this first cycle, this will start to get smaller and smaller and smaller. So more and more buildings will be covered by these requirements. So what happens to buildings that, fail to comply with the standard and also fail to comply with it after 5 years? There are some pretty big ramifications here. The ramifications specifically are fees to the tune of $10 per square foot for your building. So 100,000 square foot building could face up to $1 million in fines, capped at a total of $7.5 million. There are some other rules between that might ease the fees a little bit, but big picture, this is how they look. So to kind of summarize it, buildings in DC that fail to meet their Energy Star score targets face large fees in 2026 unless they bring their buildings into compliance with the standard. So we've talked a lot about these Energy Star targets, but common type of building in DC is this question is actually incorrect. Sorry, this question should ask for office buildings. A common type of building in DC is an office building. So I wanted to ask, what is the median Energy Star score of a office building in DC? So apologies again to folks on the line here. It's not a multifamily building, it's an office building. Go ahead and make a guess. All right. Looks like 100% of you have answered here. And the two top choices here are 61 and 71. The answers are quite across the board here. Some folks chose 51, some folks chose 81. The actual answer is 71. So that means the average office building in Washington, D.C. uses less energy than 71% of its peer buildings nationwide. So even though the median for the nationwide is 50, DC is kind of ahead of the curve when it comes to offices. Overall, across the board, buildings in DC are a little bit more average than their nationwide peers. Or excuse me, a little bit more efficient than their nationwide peers. The only category in which DC kind of underperforms the median is schools. So this is a pretty big target for commercial buildings of all stripes to meet. If buildings are not compliant, and were not compliant in 2019, say their Energy Star scores were lower than the target, there are 4 different compliance pathways to bring your building into compliance by 2026. I'm going to discuss them all in a little bit more detail, but retro commissioning specifically can help with 3 of them. The first target is the performance target, which requires you to reduce your site EUI. The second one is your standard target, requires you to just meet your Energy Star score. The last one is prescriptive, which requires you to do a few different things. And let's talk about them in detail. So like I said, let's say right now your building that you own is an office building and it has a lower Energy Star score than 71. Your first option to bring it into compliance is within 5 years, by the end of the compliance cycle, reduce your site energy consumption by 20%. So that means the total, your utility bills, what you get from Washington Gas and Electric and from PEPCO, should be reduced by a total of 20% year over year by the end of the cycle. Maybe easy for some buildings, maybe difficult. Another way of meeting it is to simply meet your Energy Star score target. If you look at the top building there, it had an Energy Star score of 69, which isn't too far off from 71. So they might not have to actually reduce their building energy usage by a whole 20% to meet the target. However, somebody who has a very, very low Energy Star score and has a very, very high target, it might be easier to just reduce your energy by 20% rather than meeting the goal. Again, retro commissioning as a means to save energy is also useful for the standard target pathway. Lastly, in relevance to retro commissioning is the prescriptive pathway. Basically, if your building doesn't comply with the BEPS standard during the first compliance cycle, you have the opportunity to implement a bunch of prescriptive measures from an a la carte menu of options. Each of these are designed to reduce your building's energy usage. There are a few stipulations that you have to do to follow this compliance path. You have to have an energy assessment, sometimes called an energy audit, done by a qualified professional. You have to submit a package to DOEE for the set of measures that you want to implement. And you also have to submit for approval a operation and maintenance plan. So if you take this kind of prescriptive route, there are some additional hoops you have to jump through, but one of the measures that you can apply is retro commissioning. So before, there was a lot of talk about BEPS. We see that clearly, it provides a serious motivator for building owners to improve their building's energy efficiency, and a lot of buildings aren't that energy efficient. Now, retro commissioning is a means to reduce building energy efficiency, to improve building energy efficiency. So I'm going to stop here and ask those on the line if you guys know what retro commissioning is. Just if you're familiar with it, maybe you've just heard about it, have some idea of what it is, go ahead and put yes. If you've literally never heard about it before and this is your first time hearing about it, please mark no. Looks like we've got 17 out of 20 folks responding. We'll give folks another couple seconds. And okay, why don't we go ahead and close the poll, Scott? So it looks like 82% of you have heard of retro commissioning in some capacity before, which is great news. So please, as we're going on today, if you have any questions or something that we're glossing over and isn't clear, please go ahead and ask us. And if you'd like additional detail about something, please go ahead and put it in the chat. So fundamentally, retro commissioning is a collaborative process involving a retro commissioning provider and building stakeholders. It isn't like a service like you get when you call somebody to come and fix something for you. It's a process that it does involve an outside provider, but also heavily involves the building staff and stakeholders. The process really achieves to answer two questions. The first is how and why are building systems currently maintained and operated the way they are? And secondly, what are potential energy conservation measures to improve building performance and which ones make sense? There are different types of energy conservation measures uncovered by the retro commissioning process, things like optimizing already present energy efficient design features. Maybe you've got efficient equipment, it just isn't working as well as it could. Addressing equipment performance and system integration issues, often caused by overrides over the years, things breaking, staff turnover, changes in people and operators. We try to make sure that building staff are adequately trained in system operations to make sure that they're actually functioning as well as they can. And lastly, looking for measures that also have synergies for improving building indoor environmental quality. Generally, retro commissioning has a lot of benefits. So rather than looking at our own anecdotes, we looked at some studies done by the Lawrence Berkeley National Laboratory in California, which is really the country's foremost expert on retro commissioning. So they did a study a few years ago of over 100 retro commissioning projects and did ranging from 10,000 to 1 million square foot, all commercial properties, and did a deep dive into how much these buildings typically saved. So of these buildings, they range in electricity savings from 5 to 15%, gas savings from 1 to 23%. The overall retro commissioning efforts had a very short payback period of, on average, 0.2 to 2.1 years. The median building saved over $45,000 in operating expenses, and some of the larger buildings saved as much as $1.8 million. They have a pretty complicated methodology for how they value energy and non-energy savings, which I can forward you the information on how they did it, but they value these energy savings as about 11 cents to 72 cents per square foot, and the non-energy savings as 10 cents to 45 cents per square foot. The payback was typically higher for smaller buildings, actually. So smaller buildings typically saw faster paybacks and bigger benefits from implementing retro commissioning, but it was effective at buildings of all scales. In this same study, this is this is a different study also conducted by the Lawrence Berkeley National Laboratory. I provided links in the slides below. This was a study of over 224 buildings with over 30 million square foot. And they just kind of trying to break down, out of the retro commissioning process, what kind of problems were discovered. And that's what's shown on the left. So, in these buildings, over almost 40% of them had problems with their air handling and air conditioning systems, causing excess energy usage. After that is the less convincingly called other, which can involve a lot of other different things, but about 40% of it and about 80% of it total is relating to the building MEP systems. Outside of first costs, this survey also asked building owners and operators to respond about what benefits they saw as an outcome of the retro commissioning process as it was complete. The biggest single benefit was equipment life. So 33% of these respondents indicated that the equipment life of their building systems had improved. An additional 21% of respondents indicated that thermal comfort was improved, and 17% indicated that indoor air quality was improved. So there are significant non-energy benefits that come out of the retro commissioning process as well.
Ajit,
Go ahead.
We got a couple of questions that I think we should try to field while we're at this point in the presentation. The first question that I think we can field right now, there's a couple others maybe we'll circle back to at the end, but the first one is, I think you answered this, the primary, in your experience, what was the primary reasons or finding that contributed to these savings? I think you just answered that with that last slide, but also in that same vein, are the savings, I believe this was shown on the previous slide, are they cents per square foot per year? What are the savings values shown there?
Okay, sorry, that was this slide right here. So the value of the energy savings at the bottom was taken as a increase in like the asset value of the project. The other savings were annualized savings, right? So these are 5 to 15% in annual savings, a payback period of totally 0.2 to 2.1 years for the retro commissioning investment. And these median savings, again, were annual savings in utility costs.
Okay. And I think there's another question about determination of equipment life when completing a life cycle analysis. I'm not sure if that's something to field now or later.
We didn't get that deep into it. The methodology of this study is I believe they did like an 8-year longitudinal study, right? So like they looked at projects that had only completed retro commissioning like over 5 years ago. I think 8 years was the minimum, and they reached out to them and they had a huge questionnaire. So they asked them, I think they asked the question a few different times in order to gauge whether buildings had a specific improvement in equipment life. But I'd be happy to share that methodology with anybody after this call.
Okay.
Okay. Anything else before we go on? Okay. All right. So where we were at was talking about some of the benefits that we got, as well as some of the reasons. So it's clear that retro commissioning has significant benefits, that it does save buildings energy, post utility costs, as well as providing non-tangible, non-energy related benefits as well. The question that we get often is, how long do these measures last? what we're looking at here is some data we pulled from a study in 2018 by Seventh Wave, a company that manages retro commissioning programs for utilities across the country. And they did a deep literature review looking at how long measures typically lasted. So the table on the left that you're seeing is the expected useful life, right? Like that's how long the retro commissioning measures persisted after implementation. So on average, we're seeing that buildings get these effects from anywhere from 5 all the way up to 14 years. Typically, we saw about a 7-year average quoted for retro commissioning activities. So if you invest in retro commissioning, you're likely not just to see those benefits the first year afterwards, but they're likely to persist for over half a decade. There are some measures that are more persistent than others. That's what you're seeing on the right. The more persistent measures are shown at the top of the graph, and less persistent measures are shown at the bottom. Things like changing thermostat settings, lighting controls, those things often aren't very persistent because it's very easy for users or building engineers to just change them back the first time they hear a complaint from an occupant. However, more fundamental measures that take place outside of easy control, like scheduling systems, changing filter types, optimizing economizers, things like this tend to be more persistent. There were a few things that really negatively impacted the persistence of retro commissioning. One of them was staff training, right? Like, so if you train the staff as part of the retro commissioning activities, persistence over 8 years was improved by like 25%. And there was a similar negative correlation with staff turnover. So the shorter the tenure of your building facility staff, the shorter the duration of retro commissioning persistence, which kind of makes sense if you think about it. The only other interesting fact there was typically persistence was correlated more with smaller buildings. So retro commissioning's effects lasted longer on smaller buildings than bigger buildings. But overall, retro commissioning is worth it. It lasts. It makes sense to do it. So we've talked a lot about what it is, what the benefits are. I want to spend a few minutes talking specifically about the retro commissioning process. So retro commissioning is, again, a collaborative process involving not just the provider, but the building staff as well, involving really 4 phases: planning, investigation, implementation, and verification. So we'll talk about each one. The planning phase has a few predefined steps. First and foremost, the owner selects a commissioning provider, also called a CXP. The owner should also designate an internal retro commissioning champion. Could be the owner, could be the property manager, could be the chief engineer. Doesn't really matter, but the process is much more successful when there is a dedicated person on the building side who feels that this is their job and their responsibility to bring this to a conclusion. The owner also assigns staff responsibilities to participate in the retro commissioning process. There may be things required from housekeeping staff, facility staff, accounting staff, just making them kind of aware that this is going to happen. That needs to happen during the planning phase. The commissioning provider usually performs a walkthrough inspection. Usually this is after the commissioning provider is contracted, but sometimes it happens before. This isn't a detailed investigation, but just enough to kind of understand, what's happening in the building. Things that the owner also provides a basic building information, equipment list, 2 years of utility bills, list of known issues. At this stage during the planning process, the commissioning provider reviews all this information and looks for kind of high-level warnings, right? Things like indications of simultaneous heating and cooling, right? Like, are we using the AC and the heat at the same time? Pumps that are running more often than they should. Air handling systems that are running in the middle of the night. Weird pressurization effects where it's hard to open or close the door. Piping that is hot or cold when it shouldn't be hot or cold. Weird noises. Spaces that are bright where the lights are on in closets when you don't expect them to be. Things like this that you can identify in just a few hours. This typical walkthrough is just like an audit. It takes just a couple of hours. Based on this kind of preliminary planning activities, the commissioning provider develops a retro commissioning plan. The retro commissioning plan should contain the goal and the scopes of the project, a list of the building and its systems, a list of the team members identified by the owners, their roles and their responsibilities, descriptions of the communication protocols, the schedule for tasks, descriptions of deliverables, documentation requests, description of means and methods, implementation considerations, and also details about project handoff. So all of this can be contained in the retro commissioning plan. Next, we move on to investigation. The commissioning provider really kind of takes over at this point. The commissioning provider holds a kickoff meeting with the project team to present the plan. They perform a thorough desk review of all building documentation, which, equipment lists, nameplate photos, drawings, as-built, previous commissioning reports, energy studies, anything at all. We'll take it and we'll review it. We interview facility staff to ask them questions about, comfort, how the building operates, its history. We perform a thorough review, where available, of the building automation system, the computerized system that controls the building MEP systems. We review trend data where available. We install meters and data loggers when needed. For some specific cases, we will write scripts for functional performance testing of major energy consuming systems. So while most of the time we try to do it with just inspection and reviewing trend data, some bigger systems have to be physically tested to make sure that they work. As an outcome of this investigation process, we typically identify, describe, and prioritize energy conservation measures to reduce your building energy usage. We include energy savings calculations, cost estimates, and simple payback analyses. And all of this is summarized in a retro commissioning investigation phase report before we go any further. Once we've had a chance to review this report and our findings with the building owner and the project team, we move on to implementation. So implementation is really the bridge between going from that investigation report to actually having actionable scopes of work that can be implemented. As a reference back to BEPS, buildings need to be compliant in 2026. So all of this work that's done, the outcomes of the retro commissioning process, need to be done and implemented in time to impact your energy usage by 2026. So really, this work needs to be done, implemented, and verified by 2025. The implementation plan should have actionable scopes for each ECM, should include deadlines, it should also include verification requirements. Then after the plan has been developed, the scope of work should actually be implemented. Things like replacing sensors, more belts and couplings, redefining set points and settings, updating programming, installing new controls. These are mostly things that are huge capital investments, but minor investments to improve your building's performance. Implementation can happen in a few different ways. It can be turnkey by some providers. This isn't always available, but it's beneficial because you only have one contract. It can be commissioning provider assisted, where the commissioning provider helps you negotiate with contractors, and kind of serves as an owner's rep, but the owner still holds the contracts. You have to deal with more contracts this way, but you can save money by not going with the turnkey provider. Lastly, implementation can be owner-led, where the owner handles implementation themselves. This has the lowest cost, but it does require the most work, and you really need to know what you're doing in order to effectively implement and verify this. So you do have a few options, but the overall process of what you do is typically the same. Scott, did you have any questions? I saw you came off mute for a second there. No? Okay. Lastly, we have verification. So retro commissioning differs from audits and other kind of assessments in that it's a process requiring implementation and verification. It isn't just about walking through your building and saying, hey, this looks like good ideas for you to do that could save money, but it's about prioritizing them, vetting them, making sure that they pay back, and developing a feasible plan for implementation, and finally verifying that these measures are having their intended effect. After these measures are implemented, the commissioning provider verifies successful implementation a few different ways. But the three primary methods are benchmarking, comparing your building against how it did in the past, doing a utility data analysis, really making sure your utility usage patterns make sense, and finally trend data. Whatever you implemented, can we use data loggers or BMS trend data to make sure that what we intended is actually performing. Other steps in the verification process are building engineer training. Systems are typically only as good as the person operating them, so it's very, very critical that whatever upgrades are implemented, that the engineer receives training on how to use these appropriately. The commissioning provider will also recommend revisions to the existing preventative maintenance plan for improved operations. So, how to do things going forward. And the provider will also develop persistent strategies like ongoing commissioning or recommissioning strategies for making sure these measures stay persistent in the future. Examples of that could be as simple as questionnaires that the building engineer asks themselves once a year. Things like, have tenants added or removed loads from the space? Were temporary occupancy schedules implemented and have they been returned back to the original settings? Was equipment worked on and locked out, and has it been restored to its original settings after that was done? Have there been changes to furniture layouts that might cause comfort complaints? Strategies, these questions to ask, tests to run, checkpoints to basically check in at to ensure persistence. These are strategies included in ongoing commissioning and recommissioning plans. Finally, all of the findings of the retro commissioning process, including investigation, implementation, and verification, are summarized in a retro commissioning report.
Nay, Ajit, we've got a request to go back to the implementation slide.
Okay.
That's all the question was. So we'll, I guess, let it sit there for a second.
Okay. Speak now, or I'll actually speak later. We can come back to your question as well.
Okay, wait, let me see. I've got one more. Just let me check. So we have a comment or question that says, given that RCX measures tend to be low cost, what is typical response you get from property owners and or property managers regarding implementation? Do they typically self-fund?
That's a great question, and we'll get into this shortly here. Typically, the way we do it is during the planning phase at the project outset, we request the owner's financial stipulations, right? Like, it really varies widely from building to building. Like, what type of, is it an income generating building versus is it an owner operated building? Are there like net or gross leases? Like, how does the owner, how does the owner basically reclaim the savings from it? So this typically shows up in acceptable payback periods. Some clients want measures that only pay back in 2 years or less. Some of them are good with measures that pay back in 7 to 10 years. So typically this shakes out in the client's payback and financial considerations.
And if I could add to that, Ajit, it depends also well on what the objectives are of the project. We've had clients who have very, ambitious energy reduction goals, and they've been willing to, go out and, arrange to get the capital they needed to implement a major renovation or operational change to realize savings. And then we have other folks who really just stick with the things they can do with their in-house staff. So, and as long as that meets their energy goals, that usually works. So one real quick heads up, Hardik, I think you have comments about costing. So we've had a question about how we cost things. So I know you'll touch on that later. If you can, just make sure you touch on kind of the different costing methods when you get to that slide. And if we don't cover it, we'll circle back at the end to respond to any questions on that.
Sounds good.
Yep. Okay. And thank you, Scott. And okay.
So one last question while we're on this, Ajit, are there templates for the implementation plan and CX report that people can use?
Yes, they can. And if you guys go through these links that I've shared here, excuse me, where was it? So the EPA has a retro commissioning manual, which is really great. And it has templates for everything, like, implementation plans, commissioning reports, owner's project requirements, everything that we've discussed are included in these links. So everything that I've referenced will be hot linked in this presentation as well.
And the slides will be shared afterwards, as well as a video of the presentation.
Correct. And all the material and references that I share here are publicly available and free and do not require any purchases. Okay. So we went through verification. I want to just take a moment to pause here and talk about RCX process deliverables. So like if you're a building owner or a provider, this is kind of the laundry list of things that you should expect to see, ask for, or deliver during this process, depending on what role you're playing. At the beginning, a retro commissioning plan, an interim retro commissioning investigation report with energy savings calculations done before implementation, A prioritized list of capital improvements for further investigation. So kind of in response to that question earlier, even though retro commissioning is focused on low and no cost measures, we do still identify capital improvements for further investigation, typically so that property managers can include this in their capital budget for the next year. You should see an implementation plan. You should see a retro commissioning final report. We should see building staff training materials, a recommissioning or an ongoing commissioning plan for helping persistence of measures, and finally meeting minutes. So there are additional deliverables and reports that can be generated, but this is kind of like the minimum quantity, minimum due diligence of what you should expect from a retro commissioning provider. Now that we've talked about what it is, how it works, what its benefits are, what to expect out of it, I want to talk a little bit about costs. So LBNL did a study in 2020 where they did over 1,500 buildings that had gone through, commercial buildings that had gone through the retro commissioning process. And they discovered that on average in 2020 dollars, the median cost of retro commissioning was 26 cents a square foot. That the average cost kind of ranged, excluding outliers, between 15 cents and 56 cents a square foot. There's lots of research out there. There's lots of different studies, but this study by the LBNL is the most recent and the largest longitudinal study of retro commissioning costs. Things can vary widely based on your situation, the provider you're pursuing, their familiarity with your building, the type of equipment and information that you provide. So these values can definitely vary widely, but that's a pretty good data point there for those of you interested in costs. The EPA retro commissioning guide for building owners identifies that most of that cost goes into planning investigation. Like 70% of that cost goes into figuring out like what the heck is going on with your building and making the plan. Implementation takes up about another 27% of that, and reporting back end stuff really takes up very little time. Want to talk about cost saving strategies for retro commissioning. Basically, there are two main strategies. One of them is do as much of the work you can as yourself so that the retro commissioning provider doesn't charge you for it. Things like that are developing a list of known issues prior to retro commissioning, right? Like just writing them down in an email and sending them to the retro commissioning provider saves time. Developing a list of current facility requirements, like what are all the thermostat set points in for all your equipment, all of your room. What is the schedule? When do people come in and leave? Having this type of information already pre-documented saves your retro commissioning provider the effort from going in and putting it together manually. That data gathering cost is a lot, right? So if you can do this yourself, it saves time. Gathering documentation required, as-built drawings, manuals, submittals, that saves a lot of time. Performing scheduled maintenance. So if you already know that you change your filters and swap your belts out once a year, do that before you start your retro commissioning process so that you don't waste time talking about it during retro commissioning. Assist with diagnostic monitoring and functional performance testing. Rather than calling a third-party contractor to run a test, have your building engineers trained and has the knowledge, have them help your commissioning provider. Diagnostic monitoring. If the retro commissioning provider needs to come and install sensors, ask your building engineer to do it themselves to save that cost. Whatever that you can do internally is cost saved in terms of retro commissioning. Lastly, performing repairments and improvements in-house. So if anything can be done by you installing parts without calling an outside contractor, good way to reduce costs. Lastly is cost sharing with tenants. This is very easy in income producing properties that have a gross lease where the owner pays all utilities, or a fixed base lease where the owner pays utilities up to a certain amount. It's harder under net leases where the tenant pays like utility costs, but there are still means. For example, leases can be identified that any changes to operating expenses can be clawed back by the owner if they were due to an owner's capital expense. So this doesn't really help existing leases, but it does help during lease renegotiation and for new leases. So regardless of how you own and operate your building, there is a way for you to realize the savings from the retro commissioning process. Retro commissioning, while it does cost money, there are a ton of incentive programs available for this. There's just a few of them, mostly run by utility programs, sometimes run by state utility boards. But here's just a sample of 10 or 12 that are around the country in major areas. You'll see some familiar names here and some less familiar names. In DC, not everybody can qualify for incentives for retro commissioning, mostly focused on affordable housing market that can participate in the retrofit accelerator. DCSEU does have a pay for performance program involving retro commissioning, but that's on a case-by-case basis during since COVID. So while in DC there are limited incentive opportunities for this, there's tons of them in and around the area, including in the DMV. PEPCO has a great offering in Maryland. So we always encourage you to look this up and see what's available in your market. A lot of these programs require that you use specific commissioning providers, like for example, ComEd in Illinois is a program that we at Bauman Consulting work with. We have to be pre-registered with them in order to offer those services. Through a longitudinal study done by 7th Wave about these utility programs, we discovered that generally 71% of participants in programs made improvements that were incentivized, that they got money from one of these programs. And that additionally, 64% of participants went on to make improvements that were not incentivized, but just because they made sense, right? Like it was worth it. So most participants will make these, implement findings or recommendations, whether or not they're incentivized, because retro commissioning almost always turns up measures that are just like, duh, common sense, let's do it. I mentioned, what incentives are available for there. Sometimes you have to choose from a predefined list, but oftentimes there's a ton of different providers out there. Like you'll go to a website and there'll be like dozens and dozens of retro commissioning providers. And they might all be good, but there's usually a right one for your project. First things to look for are certifications. I've listed a few at the top. BCA has the CCP, the CCF. AEE has the CBCP. ASHRAE has the BCXP. University of Wisconsin has QCXP. There's lots of these different certifications. There's something to look for, but generally they get your foot in the door. They don't get you on the dance floor, right? Like just because you have a certification doesn't mean you're an expert commissioning provider, but somebody without any certifications at all probably isn't taking the effort to do it. Commissioning experience. So I would look for years of experience in commissioning and specifically experience with similar buildings. Past life experience. What did this person do before they were a commissioning provider? I like to look for people who are facilities engineers, service and startup contractors, and MEP design engineers. Those people usually kind of have a great background that sets them up to work well as a retro commissioning provider. Scope of services, specifically existing building experience. Somebody can be a great commissioning provider with new buildings, but existing buildings are a different animal. It is important to ask them, what their existing building experience is, and ask them for references, and ask the references to describe the outcomes and if they were happy with what the commissioning provider did for them. Lastly, the type and number, the type of projects and the systems. If you have off-brand systems or unusual things like steam or pneumatics that aren't really done anymore, it really helps to have a commissioning provider that's worked with those systems. I've included an old steam boiler and a compressor, air compressor here. There's pictures on the right. Such systems need people who are familiar with them. So that's what to look for. Lastly, just a couple more slides before we switch to Hardik. Involvement in the retro commissioning process. Beyond the commissioning provider, the building owner and financial authority, the person who signs the bills and can say, okay, spend the money, that person has to be involved. The property manager responsible for day-to-day operations should be involved, and the building engineer should be involved. One of these people should be designated as the champion, who can be really involved throughout and act as the owner's rep and has the authority to make decisions. Also important are to involve service contractors who are currently contracted or who've worked on it before, people you like to call when things break. RCX program staff, or utility company staff, or municipal authorities. If you're doing this for DOEE or a utility program, you want to have those people involved. So again, this is a process involving a team of people. It isn't just a service given to you by one provider. Oops. I've mentioned a lot that you need documentation as part of this process once you've hired your provider and assembled your team, and this is kind of what you're looking for. You're looking for buy-in to implement these feasible and cost-effective measures, preferably in writing. That in-house champion designated financial criteria, utility bills, equipment lists, as-built MEP and architectural drawings. Lots of buildings we work in, these don't exist in soft copy. You have like a basement with a ton of binders lying around. This is a building we recently retro commissioned. That's fine, but identifying if you only have it in paper copy, having somebody scan it or take the pictures of it, it's useful. Controls drawings are very critical. So things like points lists, sequences of operation, set points that describe how your system operates. We also like to see maintenance logs, service contracts, existing copies of warranties, and really any previous studies or reports that were done on your building. So gathering this information beforehand, again, is a cost savings measure. So I'm going to stop there and ask one more poll question just to kind of see what kind of buildings people work with here. Scott, if you could launch this poll. We're going to switch gears here. My colleague Hardik is going to talk about some case studies and some lessons learned here. So we want to kind of understand, what types of buildings do you folks work with? So we've got 3 of 19 people respond so far. So go ahead and fill this in. Okay, we'll give folks just another couple seconds to respond to these polls. And okay, Scott, you can go ahead and run. All right, it looks like most folks here work with commercial office buildings, which is great news because that is exactly what Hardik is going to talk about. So Hardik, please go ahead and take it away and let me know whenever you'd like to change the slide.
Perfect. Thanks, Ajit. You can switch to the next slide. So we have our office in DC and Chicago. So we do our retro commissioning projects across the United States. So for this particular presentation, we will be trying to focus in Chicago because I work in Chicago. So we will be trying to show a case study that is based in the state of Illinois. So this is one of the energy efficiency program that is being run in the state of Illinois. So it is a utility funded energy efficiency program for the existing facility to identify no-cost, low-cost energy conservation measures. When I say utility funded, it means a part of the like all the services that we are providing as a service provider, it is being funded. Like the client doesn't need to pay anything to us. We are getting funded directly from the utility. So on an average, we are seeing an savings of almost 5% on the annual utility bills. The simple payback is less than 1.5 years for the implemented measures. After the retro commissioning process has happened, we are seeing a good improvement in the occupant comfort and reduced maintenance, and which also helps to improve the overall energy performance and energy benchmarking score for the buildings. Next. So in this type of process, there are particularly 3 stakeholders. One is this customer who owns the building. So their duty is to collaborate with the service provider and review and select all the energy saving opportunities that is being suggested by the service provider. Second is the service provider, who are the engineering consulting companies who does all the engineering work, like all the like sort of a audit, doing all the engineering calculations and verifying everything during the entire retro commissioning process. And the third stakeholder in this type of project is the third party reviewer or a utility company who reviews all the engineering calculations work that is being done by the service provider and also manages the incentives program and the offerings of the program. So within the customer, there are 3 stakeholders within the customer as well. So that includes the building engineer, property manager, and someone from the finance who will be signing all the documents with regards to the incentives and all the documentation work. So with this thing in mind, so we reached out to one of our client in Chicago. So this is a Chicago-based commercial real estate firm that offers a brokerage services to the corporate business entities across the states. So we reached out to the client directly with regards to this utility funded energy efficiency program. The building was, so the building that we will be working, like showing the case study for, is already consuming 2 gigawatt hour of annual energy. And the client was looking for some way they can reduce the overall energy consumption for this particular facility. So we started this project during the pandemic, that is back in 2021. Hence, there was a lot of vacancy in the building. So it was sort of a motivating factor for the client. Like, since the building is already unoccupied, it is the best time to implement, to work on something like this type of project. At the start of the project, the client was not at all, like, not too much motivated to go ahead with the retro commissioning, but it was the financial benefits that was being provided by the utility program that motivated the client to go ahead with this type of project. So after having a client meeting, so they wanted us to work with one of this facilities. So this is a commercial office that is in the 1960s construction, that is located in the Des Plaines, Illinois. So it is having a total building area of 126,000 square feet. And as of 2020, the building was 84% leased. The building is having an annual electric usage of 2 gigawatt hours and a peak demand of 2000 kilowatt. So when we started this project, we are supposed to decide like what type of how much target should we set for this type of retro commissioning project. So there are multiple factors that comes into place while deciding the target. So first, one methodology that we looked into is looking into the Energy Star portfolio manager for this particular building. Like, how is this building performing as compared to a similar building of similar size and facility type? Another thing that we did, we conducted a level 1 energy audit for this particular building to understand what are the current systems, what all opportunities are we seeing as part of this retro commissioning project. And third, we asked the client, like, what is there, if they have any sort of business goal, internal business goal that they would like to achieve as part of this retro commissioning process. So looking into all these three factors, we decided to set a target, or conservative target, of 10% reduction of the annual electricity consumption. This is very similar to what Ajit discussed in the previous few slides. So in the DC market, you might be saying like you have a performance path, like where you need to reduce a site UI by 20% by 2025. And for the standard target, that is the option 2, you might have a different target. So this is something that at the start of the project, we need to decide what should be the project target that we should be aiming for as part of this process. So giving a background about the system description. So this is an all electric building, which means there is no use of natural gas at all, be it for heating or hot water or cooking. So building has 2 air handling system, air handling units that serves the north and south zone of the building, that provides cooling and ventilation to the space. The cooling is being provided by 5 multi-stack water cooled chillers that is having a total cooling capacity of 136 tons. The heating is provided by perimeter electric baseboard heaters, as you can see in the image on the left. So all the one that is on the colored in red, those are the electric, the perimeter electric baseboard heaters that is serving the entire building. The building, since the building was a 1960s construction, so they have a very old VAV terminal units, which means like it is manually controlled by the tenants in the space depending upon the thermal comfort. Like, suppose if the tenants are feeling too cold, they will just close the damper manually, such that it will restrict the amount, like the cold air that is coming from the VAV terminals. And if they are feeling too hot, they will just open up the dampers. So they have a very old VAV terminal units. All the lightings are LED, and they had a BAS control, that is a Niagara BAS control system. So this is something that we can also see in office buildings in the DC market as well. We will be seeing a very similar construction where the buildings from 1960s construction, you will be seeing like they have a almost similar type of HVAC system that is there. Next. So we start off the process by performing the utility bill analysis. So once the majority of the data is collected, so we start the process, the investigation calculation, by performing the utility billing analysis for 1 year of annual electric consumption. This is the utility, like the annual consumption for the building that we are working for. So this is for the year 2020. So this graph is the daily electric consumption correlation between the daily average ambient temperature and the electric usage for the year 2020. So the the line in red represents the ambient temperature, a daily average ambient temperature, while the blue represents the overall energy usage for the entire year. As we can see from the graph, when the ambient temperature goes below 50°F, the electric usage is going up. That is, we can see for the month of January, February, and late December. We can see when the ambient temperature is going below 50°F, the electric usage is going up, which is expected since it is an all electric building. So this is one way to help us determine like majority, like a considerable amount of energy is being spent for the heating in this building. So this is the first step for us to identify, like, where is the major energy being spent for this type of building. So building analysis, doing this type of building analysis helps us to provide a very better insight on the performance of the building throughout the year, be it on the time of the day of the week, etc. So you can get a similar sort of time interval data from the PEPCO website as well. Next, we start off the investigation phase by scheduling a site visit with the building engineer. So we schedule a site visit with the building engineer and engineers from our company. So the initial site visit was for almost 2 to 3 years. It may vary depending upon the size of the building or the complexity of the HVAC system that they have. So during this site visit, we asked the building engineer for us to give access to their BEPS system, mechanical and electrical room, roof, tenant space, and occupant space, so that it provides us with a better understanding about how the systems are currently operating and what all existing conditions are there for us to determine the energy saving opportunities in the future. So during this audit, we asked several questions to the building engineer. Some of them can be like, does the building engineer receive any sort of hot or cold complaints from the tenants in the space? Interestingly, the engineer did receive several complaints from the tenants, especially for the tenants facing on the south side of the building. They were getting, the building engineer was receiving a lot of hot calls with regards to like the solar heat gain and the heating, perimeter heating that was happening. Second question that we ask is, does the building engineer receive any complaints for the indoor air quality? Has the building engineer noticed any infiltration issues as part of this building? How often does he replace the filters, and how often does he calibrate the sensors in this building? So we asked this question to the building engineer and got the feedback, especially for the sensor calibration. That is something he has never calibrated in the past decade. So that was something. So by interviewing the building engineer, we got to know like these are also additional opportunities that we should be looking into. Having as-built drawings of the building is really important, as it provides details of the building characteristics in terms of the building envelope, like how it was constructed initially in 1960s. What were the initial mechanical, electrical system that it was designed for? What was the ventilation schedule? What were the initial lighting counts? There are very high chances that the floor plan and the system changes or upgrades over a period of time. Hence, it is very necessary for us to take nameplate pictures of all the major energy consuming equipment on site. So that was something that we did for this particular project. Since it was a 1960s construction and there were several owners who changed over a period of time, the current owners did not have the original as-built drawings for this building. So they reached out to the previous owner. We got the hard copy of those drawings, but surprisingly, there were few important drawings that were missing. So one of the recommendation that we gave to the client was to always keep a soft copy of all the existing as-built drawings, which can be required at any point in the future as well. So once we have the drawings, we ensured, we verified whether all those equipments, whether they are still existing in this building or not. There are high chances, like over a period of time, they might have upgraded their equipment. So that is something. So that is the place where we do the audit, where we take the nameplate photos of each and every equipment and later on verify whether it matches with the as-built drawings or not. So the nameplate photos not only helps us for all the engineering calculations as part of the investigation phase, but it also helps us to coordinate with the equipment representative for getting additional information for the building. Like for example, so for this particular building, there was a cooling tower. They had the nameplate on the cooling tower, but it did not have the motor rating on it. So with the model number, we were able to directly reach out to the manufacturer representative to get all the information that we needed in order to perform all the engineering calculations. Next step, we look into the building management system, which is a computer-based control system installed in buildings that controls and monitors the building's mechanical and electrical equipment. It provides insight into what the current set points, schedules for each and every equipment are there in the building. Some BAS do have trend data capability as well. It provides a better insight into the building performance on a time interval basis, like it can be for minutes, days, or throughout the year as well. This was very helpful for this particular project because the time we started this project in early summer, and we were looking for energy saving opportunities during winter as well. So with the trend data capability that was available in the BAS for this building, we were able to see the building performance during fall, spring, and winter months as well. So it helped us not only to focus on the energy saving opportunities for the summer months, but also throughout the year while it was getting implemented and verified at a later stage. And the last thing that we saw for this particular building was while reviewing the BAS, we saw that the ambient temperature and the humidity sensor was for providing a faulty reading as compared to the local weather station that was located very close to this facility. So this was something that we got to know, like if we see like the entire building performance is dependent on the ambient temperature and humidity sensor. If this sensor is not calibrated annually, it can completely impact the overall building performance. So as you can see in the image at the right bottom, so that was a sensor, that a Hobo data logger that we installed on this facility. So Hobo data logger logs data like the ambient temperature and humidity data. And later on, we compare it with the sensor reading that is provided in the building. So this helped us to verify whether, like, how much was the deviation from the actual reading. So we installed this data logger for a period of 2 weeks in order to get different samples, and it was set for a 15 minutes time interval for a period of 2 weeks. Next. So once we collected all the data, so next is to identify the ECMs. So there are multiple strategies that we used in order to identify different ECMs for this particular project. So we always start with by focusing on equipment that are major energy consuming equipment. So those are like chillers, pumps, compressors, fans, cooling towers, and heating equipment. So this is the best place to see like where the additional energy is being spent. Some things that we look for as part of this project are the equipment working on schedule. So that is something like, is there any schedule that is being set for the air handling unit, or is it operating during unoccupied mode as well? Is there a separate heating and cooling set points for the occupied and unoccupied mode? And are the equipment working as per sequence of operation? Since the building was constructed in 1960s, there are high chances like the sequence of operation might have changed from the original, the way the building was designed originally. Or there are high chances like the building engineer might have override the set points at some point of time and he might have forgotten. So these are some things that we usually started to look into in order to identify ECMs. Interestingly, there was certainly few equipments that were operating for a longer time. There was few set points that were like the nighttime setback that were still operating at a very high temperature during unoccupied mode. And there was few sequence of operation that was not as per the original design intent. So right throughout the process, while we are identifying these measures, we always ensured that we are involving the building engineer and the property owner into this process at early stage itself. It not only helped us to get us a better understanding about why they are operating the system like this, but it also helps us to understand whether the owner, like the ECMs that we are recommending, whether the owner would be interested in moving forward once we do all the engineering calculations or not. It is always important to do the feasibility analysis, not only with the building engineer, but also with the contractors who will be implementing these measures. Because not each and every measures that we think about can be converted into reality. So it is always the best practice that we followed as part of this project was to ensure like we are doing the feasibility check analysis and also involving building engineer and property owners throughout the process during the investigation phase. Next slide. So once we identified the ECMs and reached out to the customers, so we start with the engineering saving calculations. So depending upon the utility, so there can be a few standard calculators that are already developed by utilities that we need to use, but there can also be where you can develop your own custom calculators as per these guidelines that is set by the utility program. So there are certainly a few approved third-party modeling software that can be used as part of the calculation methodology, but it needs to be confirmed by the utility whether they would be whether it would be okay for them if we go ahead with the energy modeling software as part of the calculations for as part of the reactor commissioning process. So while doing all the engineering calculations, always ensure that we are looking into the measurement and verification guidelines that is set by the utility program. So this is the one on the left is one of the standard calculators that was developed by the utility program that we are currently working for this project. And the next, you will see this. So this is one of this custom calculator that we developed in-house for the building warm-up strategy. So depending upon, so there are certainly several formulas that are available online that you can use in order to doing all the engineering calculations. As part of this project, we used all the Excel-based formulas, Excel-based calculators for performing all our investigation and verification calculation. So we use the TMY3 data file for the Chicago location and all the temperature bin analysis for getting annual energy savings for each and every measures that we are recommending as part of the reactor commissioning process.
Hey, Hardik, we have a question about how tenant comfort issues are addressed and or verified after implementation of PCMs.
So tenant comfort. So we do the tenant survey. So after the measures are implemented, so we reached out to the customers. We asked them whether they are feeling comfortable by implementing those measures. We don't go into the too technical stuff, but we just do a survey like, are they feeling comfortable in the past few weeks? Whether if there is any sort of complaints like they are feeling too hot or too cold. So we try to adjust our implementation, like the sequence of operation accordingly, and try to ensure that the tenants are feeling comfortable in the space.
Okay, thanks.
Yep. Next, we start. So while after all the engineering calculations are completed, we do the pricing and the implementation coordination with the contractors. Like in energy audit, it is okay to provide an estimated cost for implementing any measures, which can be done by RS means or any other online cost estimate tools or database that are currently available. But in this particular project, in this reactor commissioning project, so we had to provide actual cost for implementing any of the measure. So this is something that is a guideline that is being set by the utility program that we need to provide the actual cost for implementing those. So at the start of the project itself, so we reached out to the client whether they would be looking for competitive bids from multiple contractors or they are okay to go ahead with one bid as well. And another question that we asked to the customer, whether they have any preferred contractors they would like to work with. Because there are several buildings where we see like the customer usually prefers to work with the same contractors because they have been working for several years and they understand the building much better rather than involving a new contractors as part of this process. So it's always better to ask the customer like what is their preference. So in this project, the customer already had a preferred contractors to work with. So we reached out to them. So initially when we started the costing analysis, we directly reached out to the contractors, like we are working on this reactor commissioning project and we want to implement some of the ECMs. At the initial start of the process, it was a bit difficult for the contractors to understand like what exactly are we trying to do. but that is something that we implemented as part of this process. So we came up with a scope of work document. So it is a document that replicates the exact scope of work for the contractors, which includes, like, suppose, like, what was the initial baseline condition? Like, for example, for duct static pressure reset, like, how was the building initially operating? What was the initial set points for the duct static pressure reset? And after implementing those measures, like, what is the outcome? Like, what changes should we seeing in this by implementing this measure? So this provides a good guideline for the contractors, like what is their exact scope of work and what is the outcome that is expected after implementing those measures. It is a very good document process that we involved. It helped us to avoid misunderstanding in the future. So while preparing this document, we always try to ensure and inform the contractors like there is no sort of impact on the IAQ and the health and safety of the tenants in the building. So always provide that sort of guidelines to the contractors. And also we provided sort of a timeline as well to the contractors, like within how many days after the investigation phase, they need to complete this implementation phase in order to meet the project timeline. So these are the few documentation that we completed. And so next I will be talking about some of the ECMs that we identified as part of this building. So starting with, so one of the ECM that we identified was scheduling the air handling unit. So the graph over here represents a demand heat map during the investigation phase. As we can see, on every Mondays, the air handling unit was starting at 2 a.m. That was something while the building tenants were coming at 7 a.m. So every time the building was operating for additional hours, and it was consuming more energy. So we did all the investigation calc from our end, and based on the return air temperature, we were able to see, like, even if this building starts the system at 6 a.m., they will be able to reach the desired set point within 25 to 30 minutes. So this is something sort of a strategy that we use, like looking into the graphs, like able to determine the ECM and doing all the engineering calculations based on that. So by implementing this measure, the building will be able to save almost 87,000 kilowatt hour of energy annually. The implementation cost for this particular building was zero, just because this is something that can be done internally by the building engineer. So it was just about changing the schedule. Like, instead of starting the system at 2 a.m., he was just supposed to start the system at 6 a.m. And so that's why the implementation cost for this building, for this ECM, was zero. Next ECM that we identified, looking into the set points. So nighttime setback for the electric heating. So during unoccupied mode, that is between 6 p.m. and 8 p.m., we found that the unoccupied set point for this particular building was set between 63 and 72. And due to which it was continuously consuming more and more energy for heating. So that is one place that we identified. By changing the set points, like lowering down to 60 during unoccupied mode, the building will be able to save energy for their electric baseboard heaters. So by implementing this measure, the building will be able to save 76,000 kilowatt hour of energy annually. And the implementation cost again for this ECM is zero, because this is something the building engineer can do in-house. And the next ECM that we identified was the sequence of operation. As I already mentioned earlier, like over a period of time, there are high chances like the sequence of operation might change since it was not recommissioned properly. So this is something. So looking into the trend data and the utility bill, we came to know, like, the OA damper, while the building warm up was happening during the investigation phase, the OA damper was not completely closed. It was continuously bringing in outside air, due to which it was taking a lot of time for the building to reach the desired set point during the early morning time. So by upgrading the sequence of operation, by closing the OA damper during the building warm-up time, the building will be able to save almost 34,000 kilowatt hour of energy annually. Since there will be a programming update that will be needed as part of this ECM, so we reached out to the controls contractor, and he provided us with a costing of almost $1,100 for this ECM. So in this project, as part of the investigation phase, we were able to identify 10 ECMs. So a total of 334,000 kilowatt hour of annual energy savings, which had a implementation cost of $11,500. While there are few ECMs that do have a simple payback of greater than 15 years, but there was certainly, like, if we look into the overall payback for this entire project, the overall payback was less than 1 year. So that was sort of a motivating factor for the client. So after we prepared this report, so we conducted an investigation review meeting with the client, where we went through each and every measure in more detail, like what all changes will be made in the controls or in the set points, what will be the energy saving for each and every ECM, what is the implementation cost, and what is the payback. So after the review meeting, client was not interested in pursuing one of the measure, that is the lighting controls in the restroom, because they felt like it might hinder the overall occupant experience while if the lights are not turning on at a right time. So we reached out to the client, and so during the investigation phase itself, it is not mandatory for the client to implement each and every measure. The client has the option to decide like which measure they want to go ahead with. So as part of this project, the client decided to pursue 9 ECMs in total. Next, so once all the measures were implemented by the contractors, so we went into the verification phase. It is very important to verify the measure persistence, not only from the implementation, not only if they are implemented properly, but if they are staying implemented for a longer time. That is where you will be able to see the energy saving for a longer period of time. So during this verification phase, we coordinated with the controls contractor and the mechanical contractor, just always ensuring whether the measures are implemented as per the intent, as they were intended or not. There were certainly few deviations that we saw while during the implementation phase, like one of them being like the optimum start-stop sequence that we recommended. So we did try multiple iterations to get it, ensure like if it is working properly. But since the building was designed in such a way, like it was a bit difficult for the optimum start-stop sequence to get implemented properly in this building. So that was a measure that we did not pursue at the end. So this is a final verification. So we started this project with a 10% target for the building. So during the investigation phase, we were able to identify almost 16% of energy saving. And by the time we completed the verification, we claimed the savings for almost 293,000 kilowatt hour. That is almost 14% of the annual energy consumption. So the overall implementation cost for all the measures that were implemented was $8,800, and the simple payback for entire project was less than a year. So there was certainly very good financial benefits, incentives, and the environmental benefit that were there as part of this project. As part of the retro commissioning project, the utilities provided incentives of almost $5,000. So that helped to reduce the overall implementation cost to $3,800. That is almost 56% of the implementation cost was covered by the energy efficiency program. That helped us to reduce the payback with incentives from 0.6 years to 0.3 years. And these were the overall environmental benefits that were as part of this project. This is something that was a sort of a motivating factor for the client. It was not only the energy aspect that the company was looking for, but it was also the sustainability perspective as part of their ESG reporting that they plan to use. So next we have the poll question. Have you worked on any retro commissioning project before?
So while we have that poll going on, there was a question raised about the utility paying for the commissioning services, and I can just answer that question. For this particular program, the utility does pay for the commissioning provider services. So in a project where the owner would be paying for that, there would be additional cost associated with the activities, and so some of those paybacks would potentially be longer. But I would say, generally speaking, looking at the numbers that Hardik shared, that would be maybe stretching those from just under 1 year to maybe a 2 2.5 year type payback when you add in commissioning costs, you know, that if you're paying for those directly out of your own budget.
Perfect. Okay, so we have the answers for the polls. I see that 92% of the people haven't worked on the retro commissioning project before. So I think it's a good thing, because I will be in the next few slides, I will be sharing you few good energy conservation measures that we have seen in the DC market that will be very helpful for you to get started in the retro commissioning project.
And Hardik, just mindful of our time, we've got less than 8 minutes till our hour's up, our hour and a half is up. So just
Yes.
keep that in mind as you wrap up. Thanks.
Yep. So these are few major energy, like the energy conservation measures that we are seeing in the DC market for the heating. One of them being the installing a thermostatic radiator valves. Majority of the steam, like the old steam boilers that they just have the low and high temperature set point, and they often we have seen like they just leave it at that. So by installing a thermostatic radiator valves, it can help you to regulate the it can help you to control the temperature in the room by changing the flow of the hot water or the steam to the radiator. Next is the hot water supply temperature reset based on ambient temperature. So usually depending what we are seeing for majority of the hot water equipment that are there in the DC market, like they are providing hot water at a constant temperature throughout the year. So even when the demand for the hot water is very less, that is during the cool months, it is supplying hot water at a higher temperature. So by changing the hot water supply temperature based on ambient temperature, it can help you to save energy. Next is installing a domestic water heater timers, that is operating your domestic water heater depending upon the usage when it is occupied and unoccupied. So it can help you to save energy out for the domestic water heater. Next is focusing on the building envelope. That is the cool roof strategy. Cool roof usually helps to reflect majority of the sunlight and absorb less heat from the traditional roof. So this is something that can help to reduce the overall heat gain for the top floors of the building. That can help overall reduce the overall cooling load for your building as well. And next is the building envelope sealing. So very often where we see, like for old buildings, like especially in 1960s and 70s construction, we see there is a lot of infiltration that is happening, be it like the weather stripping is not done on time, or there's a clocking, or the window openings are being found. So this is a place where majority of the conditioned air is lost into the environment, due to which the energy consumption goes up. So by providing a proper building envelope and sealing those, it can help you to save a lot of energy. Next is focusing on the ECMs for the controls, that is the air side economizer. So usually what we see, the building uses chillers and compressors for providing cooling into the building. But whenever the ambient temperature is less than the return air temperature, you can use the advantage of bringing in outside cold air into the building for cooling. So this is, in other words, this is also known as free cooling strategy as part of the retro commissioning. Next is the nighttime setback. So this is something that I explained in a few slides ago. So whenever during unoccupied mode, when we see that the building is unoccupied, you can change the set points from occupied to unoccupied. So for example, instead of keeping your nighttime setback set points at 70 for heating and 72 for cooling, you can bring it down to like 60 for heating and 80 for cooling. So this will help you to save energy. And another one is the chilled water supply temperature reset. So depending upon the return air temperature, the chilled water, the building automation system will decide, like it will change the chilled water supply temperature to the cooling coils that will help to save energy as part of the sequence. Next on the control side is the optimum start stop. So instead of starting the system at a fixed time, be it 5 a.m. or 6 a.m., let the BAS decide what is the best time to start the system. So the BAS will be looking into the building load, like how much is the cooling load or how much is the heating load, what is the ambient temperature when the building is getting occupied. So depending upon these various factors, the building automation system will decide what is the best time to start your system and help you to save energy. And last but not the least is the supply fan differential pressure reset. So what we are currently saying for few commercial buildings in the DC market. Like they are operating this fans at a constant static pressure all the time, even when the building is less occupied. So this is a place where we can save energy by changing or ramping up or ramping down the fan speed. You can change the static pressure and help and then save energy by implementing this measure. Yep, Ajit.
Thanks, Hardik. So thank you all. Sorry, we went a little bit over here. A lot to talk about with retro commissioning. Just a few conclusions. DC, there's really other places have the utilities offering a carrot to retro commission. DC offers the stick where you will face a fee if your building doesn't comply with BEPS. But regardless, the process is the same. Retro commissioning is a process that can help any building owner reduce their building energy usage. Successful projects require a collaborative effort involving the building staff and not just a provider. And while this is a customized process, involved, custom tailored for every building, there are some common ECMs that Hardik discussed, which might be well applicable to you. So thank you all for attending our presentation. And we still have a couple minutes left for a few questions here, Scott, if any have filtered in.
Yeah, maybe take one or two questions if there are any more left. I think we covered most of them. There was a question earlier that I don't know that we answered about life cycle determination. I'll give my answer to that. We look at typical life cycles from ASHRAE. There's an ASHRAE guide or standard that talks about typical life cycles, and we look at existing life, and we'll also do some evaluation of equipment condition when we're looking at projecting out life expectancy for equipment. We might also look at things like type of refrigerant. If it's using a refrigerant that's phased out or phasing out, we would assume that equipment is going to need to be replaced sooner rather than later. But it's an engineering judgment on that one.